My name is Elizabeth Heckard, and I will be reading off of my notes today. So my first my first letter I got was Y, the molecular formula being 10 carbons, 14 hydrogens, and 1 oxygen. And these were the three spectrographs I was given. So to start off with this first IR spectrograph, we can see here peaks seen at 3000, 1610, and 1510, likely pointing to a CH stretch, so a single bond between a carbon and a hydrogen, a double bond between a carbon and an oxygen, and then a single bond between a carbon and an oxygen. The second being a carbonyl, and the third being likely aromatic related, so an aromatic ring. And again, that is corresponding to this first graph. The second table shows chemical shifts due to the MMR spectrograph, seen secondly here. So we see between the 0 to 50 ppm, 24, 32, and 55, likely corresponding to single bonds between two carbons and an oxygen, and then a single bond between a carbon and an oxygen. There are also between the 50 and 160 ppm, we see 114, 128, 141, and 158, showing double bonds between two carbons and likely pointing to aromatic rings. And we can see here from the second graph. All right, and the last table we have for this chemical shift, which is this third graph, we see peaks at 1.3, 2.9, 3.8, 6.95, and 7.45. The first chemical shift showing 6 protons and multiplicity of a doublet. This is likely pointing to CH3 methyl groups. 2.9 showing 1 proton and having a quintet multiplicity, showing a single bond between a carbon and a hydrogen. The third, 3.8, showing 3 protons and a singlet multiplicity, showing a bond between an oxygen and a methyl group. The fourth, 6.95, showing 2 protons and a multiplicity of a doublet, likely pointing to aromatic ring protons or a benzene ring. And the 7.45 is 2 protons, also a multiplicity of doublet, and again, those aromatic ring protons or benzene ring. Now, this third, the 3.8 chemical shift between oxygen and a methyl group, this is pointing to, this interpretation of this last table is pointing to a substituted aromatic ring, showing a benzene ring and some isopropyl group. So these first two table rows. So coming all together, an aromatic ring plus a methoxy group, which is the third row, this oxygen plus a methyl group, and then an isopropyl group, which shows these first 2 rows. And we can see this methoxy group, third row, is at position 3 with the isopropyl at position 4. These 2 rows. And we can see here the structure. You can zoom in a little bit. This is the structure that we're showing. So the aromatic ring plus the methyl group, methoxy group shown here, and then the isopropyl group as well. And this is the molecular formula shown at the top. So you can see 12 carbons, 16 hydrogens, and 2 oxygens, and how we got the formula equal to 5. So again, we have those 12 carbons, 16 hydrogens, and 2 oxygens, and I have my formula here. All right. And now I'll go to my second number. So my second letter, was H. So a molecular formula of 10 carbons, 12 hydrogens, and 1 oxygen. Again, I had these 3 spectrographs. So in looking at the first one, this IR spectrograph, corresponding table, we see peaks at 2995 and 1700, likely relating to a carbon-hydrogen stretch, and then a double bond between a carbon and oxygen stretch, likely pointing